Everyone, in this tutorial we are going to learn how we can plot a cross-section of reflectivities with a mountain height for the WRF model output by using Python. And the outcome of this tutorial will be an image like this one, where we have the height in the y-axis and also the longitude in the x-axis. And as you can see here, brown color here is the mountain height, and the reflectivities are plot with the color bars here. Okay, we start our tutorial today, and first we need to import libraries. There is a certain number of libraries that we need to import it. However, I'm not going to detail what it is, but certainly you can search for more information in Google. And next step is we loading the data. First, we need to specify where is the location of the data. And then next, we need to specify, we need to use the dataset function that we used from the NestGF4 to import the NestGF file. And then the next step is that we need to take out the variables because we want to plot the cross section, so that it is necessary to have a fixed latitude or fixed longitude. In this tutorial, we have a fixed latitude at minus 35.9, and the longitude is from 145.5 to 150. And the next step is that we extract variables from the WRF output. Z here is the height, and TER here is terrain, and DBZ here is the reflectivity, and MDBZ here is the maximum reflectivities. These three lines of code are for reflectivity from the WRF, and the get var mean this reflectivity is a diagnosed variables from the WRF model. And in this command line, we are going to use the function vertical cross to plot the vertical cross section. There are certain inputs that we need to supply for this function. For example, z is the calculation right here, and ht is the height, and also the WRF in NC file is our NC file name here. We also need to put the cross start and cross end and for the function. After this function is calculated, because we are using SRA, so that we need to add the attributes for the variables again. So the next step is that about this section of the code. We need to fill out the gap between the reflectivity and the mountain height, because reflectivity will be a shaded patterns, and its variables, its value is at each grid point, so that at the lowest level there will be certain mismatch with the vertical mountain height, so that we need to fill out the gap. So when we have a terrain height, and we also want to have a terrain height along the cross-section line of the reflectivities, so that we use the interpolation function as specified here to do that. And then we get the longitude and latitude by using the lat long coordinates command. And this is also a WRF the built-in function that you only need to load it right at the beginning. Lat long coordinates right here in order to use it. And then the final step is we are going to plot the figure. And to plot the figure, we need to use the matplotlib, and all of this lab code is for a color bar. We specify the level is mean the interval in the color bar, and then what kind of color we want to be at that each interval by using this lab code. And then in order to plot the cross section, we use this function and Control F. This is also a matplotlib, so you just need to visit the matplotlib Python website to learn more how we can plot the contour line. And then we also need to supply the information for this function. And after the figure plot the contours, we need to, for the reflectivity, we need to add the color bar for it. Color bar is something like this one. So the contour F plot the contour like this, and the color bar is here. So we can see the color bar from 5 to probably 75, and at every 5 interval. That's why we have from 5 to 75 and 5 here. And then at each interval we have a different colors. That's why this number stands for. Yeah, and then after we have a contour line for the reflectivities here, we have the color bars for the reflectivities here, and then we need to fill out the mountain. So we fill out the mountain by using the fill between comment function. So with the color is sort of brown, and between the x-axis, the longitude axis, and the interpolation line that we used before. And after that we can add x sticks for longitude and latitude, and the labels, and also the range of the y-axis from 0 to 5 kilometers, and then we add the title for it. And then yeah, this is our final plot. So it's probably maybe rain on the top of the mountain here. Yeah, we have reflectivities in the shaded areas here, and the mountain high. Yeah, it's all done. Thank you very much for watching. Please feel free to let me know if there is any other analysis that you would like me to do, and feel free to subscribe my YouTube channel too. And thank you very much.